Hey, welcome to 16-Bit Bench, Matt here. Today I'm fixing a customer's Sinclair Spectrum 128K plus 2. This is the plus 2A model. It's the, you can tell because it's the black, darker grey one. The plus 2, the original plus 2 looks like this. It's much lighter grey and it's a bit more shonky. I do much prefer the plus 2A and ultimately the plus 2B. Because the design's been refined and they work really well. That being said, this one has a problem, and an interesting problem, and not one that I've seen before. Seems to be that common. So when this guy boots up, if you go into the 128K basic or the calculator mode and you press any key, it immediately crashes and reverts to the 48K syntax mode, which is the one. So the difference between those two modes is if you're entering a program in the 128K mode, you would go 10 print and you type print and like that. If you're using the 48K basic, you go 10, press P, and it would automatically populate print. And you need to know what all the key codes are. So if you look at the keyboard of a 48K, and here's one that has all sorts of problems. You can see on each key is printed the syntax for basic. So each key represents a basic command, and then you can use symbol shift and shift to like select different commands basically to write your programs with. So if I press P, I get print, right, and etc. And all the other ones. Say R is run and G is go to and all that stuff. So in the 128K basic, you don't have those commands. You type the whole words in yourself. That makes it easier to pick up and learn, but it makes it once you do know it, it takes longer. 48K basic, once you learn it, is much quicker because you're just hitting single keys and typing in a lot less. But anyway, what we need to do is investigate this problem. So first thing, we'll go and plug it into the television and take a look. And as if by magic, here we are plugged in and turned on. So here's the boot menu. So basically what this menu allows you to do is select between several different ROMs that are stored in the memory in the ROM. So I've got the tape loader where I want to load a game, plus 3 basic, which is incorrectly labeled. That should be called 128 basic. The calculator mode and the 48 basic. So if we go into plus 3 basic and hit enter, now we're in the basic prompt, and here's where I would type my program. So let's go ahead and do that. Oh no, it rebooted. It's actually booted back to the 48K basic menu. So now if I type anything, I need to know my keyboard command. So print. So let's reset it. And I'm finding if I go into any of the 128 modes, it will reset. So let's do the calculator. Here we are in the calculator. Let's do 6 plus. Oh no, it rebooted again. How annoying. So yeah, interesting. So what we've got to assume here is we have some kind of logic problem. We have some kind of problem. It's a high level problem. A low-level problem would be some kind of memory corruption, or the games won't load, or the whole thing doesn't power on. Those are low-level problems. So what we're looking here is a high-level problem. So it's got to be something to do with the processor, or the mode it's in, or the RAM, or not the RAM, the ROMs, or something like that. We've got to think along those lines. So this is where diagnostics tools come in really useful, and I've mentioned it in previous videos. This is the Retroleum smart card made by Phil Rushton. There's a link in the description to his website. This is super useful for all of the ZX Spectrum family. If you're interested in repairing, Spectrums, and you're doing more than say 3 or 4, this costs about 20 quid, 25 quid, and it's way worth that, easily worth that. After you've fixed about your 3rd or 4th Spectrum, it's paid for itself. So, if you're fixing Spectrums to resell or for collecting purposes, this well worth it. So what we're going to do now is, obviously you can't plug the card in while it's turned on. We're going to turn it off, plug the card in, and look at the diagnostics. When you power it up, the card will do a RAM test on the 48K RAM, because it is designed for the 48K Spectrums. But it does have a 128K menu, so we'll go into that. So here is our 128K test menu, and so here we can run through various tests to check the function of the machine. So there's a memory test, and that will test the upper and lower, that will test all 128K of memory, which is really useful for finding out if there's a fault in anything above the original 48K. The video page test just does video swapping between the video banks. The ROM test is what we're going to run in a second, and the AY sound chip test is to test the sound chip. So we are going to run the ROM test, which is option 3. Okay, so ROM test completes really quickly, and you can see what the problem is here. ROMs 0 and 1 are corrupted. It should say 128K, Spectrum plus 2A/B, 128 basic, and then something else as well. So it can't read those, they're corrupted, they've died. So that makes our next step pretty easy. What we need to do is grab a compatible ROM chip and burn it to replace the corrupted ROM. And then we can test the ROMs at fault by swapping out with a known good machine. So why don't we do that first, and I'll show you what a known good machine would report in this position. Okay, so I've plugged in a known good machine, so let's run option 3, the ROM test. And immediately it's reporting that ROM bank 0 and 1 are known and are present. They're the editor and the syntax for the 128 basic, basically. So what we need to do now is we need to take the good ROM chip out of here and read it in a chip reader, and then write to a known good ROM, and then replace the ROM in the broken machine. So let's do that. We've got the lid off our donor Spectrum. Our 2 ROMs are here in IC7 and IC8 on the board. So I've already, before I started doing this video, diagnosed the issue, obviously, and I'd swapped out the ROM. So by swapping this ROM into the bad machine worked fine. So that told me that either that this is ROM bank 0 and 1 that I need to swap out. Without the Retroleum card, I wouldn't have really known which direction to go to. But this probably, if you had a spare donor board, this probably would have been one of the first things you tried. You'd get a good known machine and you swap the components with the bad machine until the problem went away. The Retroleum card just allowed me to get straight to where the problem was, which was the corrupted ROM. So what I have ordered is some single-use ROMs that we can burn in the EEPROM reader. And they are 2756 ROMs. They're pretty standard, and they're pin compatible with the Amstrad ROMs that are used here. They're actually exactly the same if you get them the right way up. So what we should be able to do is take this ROM out, put it into our reader, and our reader is just one of these Mini Pro TL 866 readers. They're super cheap on eBay, and they're really reliable, and they've been really useful to me. So we're going to pull this chip out, and we're going to put it in here, and we're going to read it, and then we're going to write to that one. So what would you do if you didn't have a good known Spectrum to copy the ROM from? Well, there are resources online. There's this page from Phil Kendall, and this is linked in the description, and it's a list of all the ROMs that were basically used with the Spectrum, and some of them are downloadable. So for our purposes here, we'd have the +20 ROM, which has the 120K 8K editor in it, and that will be the file that we need. But we have a good known ROM, so we don't need to do that. Another resource you're going to want to look at was this one. So this is how to install the +3E ROM in your system, and that is a new ROM that supports IDE hard drives on the +3 model, and some other tweaks and functions. Now, I'm not going to do that in this instance, but this was a useful page for me working out which chips were compatible with the Spectrum and which chips I needed to buy. So if you see here, they say like the 27C256. These are one-shot, one-time programmable ROMs. So once I program this ROM, it's burnt forever, and I can't erase it, and it's basically no good to us anymore. So if we go to the Mini Pro programmer, we want to select the model of our ROM that we're going to write to, because it's pin compatible with the Amstrad ROM, and we can use that setting to read from it as well. So this is the AT27C256R. So when I type that in here, I get an Atmel product. That's what AT stands for. It's in the DIP28 package, so it's this one up here. It's not the HC, it's the C, so we select that. Then I want to read from my chip. You want to make sure that this check ID is deselected, because the ID for the Amstrad chip does not match the IC ID, so you'll get an error. So you unselect the check ID in the options section here, click read, and now we'll read the ROM. So how do we know that we've actually obtained a good ROM image and not just some garbage? So if you select a ROM IC here that's not compatible with the IC you've got plugged in, you may very well get data, but you'll get garbage data, and then writing that to the ROM does you no good, because then it just doesn't work. So to verify it, there's a couple of ways. On here, Phil has supplied the SHA256 hash that you could write this ROM out, create a 256 hash from it, and then compare that with this list here to see if you've got it right. But the easier way is just to go down the ASCII column here, and what we can see is we've got some human readable words: 1982, 1986, 1987, Amstrad, and those are the words that appear when the menu first boots up. So I'm thinking if we scroll through here, we'll get some more words. There we have. These are the options in the menu. So if we really wanted to, we could edit this to remove the reference to +3 basic, and we could actually have it say 128 basic, but I don't want to do that, because that would be pedantry and dangerous. If I wasn't using a one-shot ROM, maybe we could play about, but we are using a one-shot ROM. So what I'm going to do is I'm going to take out the Amstrad ROM, and I'm going to put in my blank EEPROM, and now we're going to program that EEPROM, and it's just as easy as clicking this button. And if you've watched any of my videos, you've seen me do some EEPROM programming before. So this, again, the Mini Pro, if you're doing any kind of retro computing or any kind of stuff like this, really useful. Really get one. They're super useful. So let's program this ROM image. Okay, and our programming was successful. Now we can verify that by hitting verify, and that compares the code in the window to the code on the chip and says they're the same. We can also read from the chip, and that will now put the code from the chip into the window, and we can just scroll down and we can see, again, human readable words here. We can see the menus, we can see the options. Super useful. So that's our programming done. Our next step is to take our programmed ROM and I'm going to put it into our known good machine just to verify that it works. Okay, so this is our known good machine. This isn't the broken one quite yet. And I've booted it up. I haven't touched it yet. So here's the loader menu, and we'll just go through the same steps that we went through before. So +3 basic. Yeah, I can type in there. So I know that at least the ROM is functioning as we expected. Let's just check this syntax. So if I type a word like prompt, it should give me a syntax error when I hit return. Yep. Oh, forget that how useful backspace was. Okay, so I know the syntax is working, I know the editor's working, and with the bad ROM it just rebooted. So what we can do is we can take the ROM chip now out of this spectrum, and we can put it in our bad machine and verify that works. So here's our bad machine. What we're going to do is swap in our good ROM that we just made here, and we've tested now on our good machine. So one thing to take note of is that all of the ICs in the +2 and the +3 are pin 1 facing south. Most circuit boards usually have pin 1, facing north, so the top of the board, but this one has it to the bottom of the board, with reference to the screen printing. which is, you know, slightly weird, but okay, interesting design choice. So to get the ROM out, I'm just going to use a spudger. One thing I did notice is these ROMs were pretty scratched up. Like it's like they've been kicking around on the floor or something before they were installed in the machine. So it's quite easy to pop these guys out. You just need to get the spudger. Maybe I'll get a spudger that isn't so bent up at the end. Yeah, there's one. Just get the spudger between the ROM and the socket. And I didn't say before, but one of the really useful things here is that all the chips that are, you know, problem chips, so the ROMs, the Z80 and the RAM. So there's the Z80 and here's the RAM down here. We're all on sockets. You can just pull them out. The only bad thing is the ULA, which is this guy here, is on some kind of like dip package that's soldered from the back of the board. So if you get a +2 that has a bad ULA, there's nothing you can really do. They don't make a replacement for this. No one's bothered to engineer one. I'm sure they will probably at some point, but it is tricky. And anything that replaces this is going to have some daughter board and something, because that's quite a unique form factor. So this is our bad chip that we've taken out, and this is our good chip that we're going to put in. Again, pin 1 is facing south, so it's away from you if you're doing it upside down like I am, but it's yeah. So all we got to do is just round the pins off a little bit, because they do come splayed out, you know, when you get a fresh chip. That's how you know they're fresh. And that's not a joke, you know. If someone's selling you new chips or newer stock chips and they slot straight into sockets, then you got to ask yourself, where's this chip been? Sometimes with the sockets, what you might want to do is just wiggle it up and down a little bit, and make sure it's pushed flush all the way home, because sometimes they can sit a little bit proud. Okay, so our ROM's now installed, and what we're going to do is put the keyboard back into it. And I have more work to do on this board, so I'm not gonna screw it up or, you know, screw it back together or anything. I'm just going to put the keyboard membranes back in place, because we need to use the keyboard. What I really need to have is some kind of external keyboard that plugs into the edge connector or something. That would be handy for this stuff. Okay, so yeah, all we do is we plug this back into the TV and we check it works. This guy is pretty much useless. It's a one-shot ROM again, so it's not like we can reprogram it. What I might do is I might plug it into the programmer anyway and just take a look at how it's corrupted. But it's probably completely dead. Well, actually, it's not, because it's got the menu on it. Maybe the menu's on the other ROM. Yeah, if that ROM's completely dead, the menu must be on the other ROM. But anyway, let's fire this baby up and check it works. Right, so we're back over here. This is our bad Spectrum plugged in. So if you recall from the start of the video, the problem was that if I went into any of the 128K editors, what I'd find is the Spectrum reset into the 48K mode. So let's just go into the +3 basic. And again, I'd only have to hit one key and the syntax would fail. So I can see immediately that we've resolved this particular problem. There we go. So yeah, that's this fix resolved. So what was the problem? Well, the problem was they had a corrupted ROM bank 0, and the way we worked that out was by noticing that the keyboard reset when we went into the editor. So we then used our Retroleum smart card, and again, I can't recommend this thing highly enough. This is perfect for this kind of stuff. Used a Retroleum smart card to diagnose the fault. By checking the ROMs in the 128K menu, it showed us that ROM bank 0 and 1 were corrupted and were no longer any good. We then used the donor machine to copy off ROM bank 0 and 1 from a known good working ROM and burn it onto a 26C256 Atmel one-shot ROM. We then tested that ROM in the good machine, because the good machine was open at the time and that seemed to make sense, and it worked in that one fine. So we went back to our broken machine, opened it back up, put the new ROM in it, and here we are. Works. So if you found this video useful, please like and subscribe. Follow us on Facebook, Twitter and Instagram at 16-bit bench. This one was an interesting one. Really had a good time figuring this one out. And, you know, that self-satisfied feeling where you solve a problem. Yeah, so thanks for watching, and we'll see you next time.